The last service in our system is the info service. As a refresher, let's remember what this service is supposed to do. The service allows end users to query the data stored in the data store and displays the data in various forms. Note that the service is responsible only for the data retrieval. It does not display the data. That is the responsibility of the client, whatever client it is. So first, let's decide on the application type here. Well, that's actually an easy one. We have a service that should be accessed by various clients in order to perform some queries. That's a textbook for Web API service, since Web API is accessible for almost any type of client and it waits for a client request before sending the response. So that's settled. Now to the technology stack. Here too, the decision is quite easy. We already decided to use .NET Core for the receiver service, which is also a web API, and there is no real reason to pick other technology for the info service. So we are going to use .NET Core for this one too. Now to the architecture. Looking at the classic layered architecture, it looks like a perfect fit. We need a service interface, obviously. We definitely need a business logic layer to validate the requests, and of course we need a data access layer to access the database and retrieve the data. And let's not forget the logging. So, is that all? Well, not exactly. One of the important steps in the architecture phase is to define the exact methods of the API. Now, we didn't do it in the receiver service since the methods were dictated by the devices, but here we are in a different situation and we can decide what actions we want to expose as part of the API. So, after discussing it with the client, it looks like what really interests the end users are two types of information: current status of devices and past events. Also, end users want to see the status of a specific device as well as a high-level view of all the devices in a specific smart home. So that means our API should have the following functionality. 1. Get all the updates for a specific house's devices for a given time range. Get the updates for a specific device for a given time range. Get the current status of all the devices in a specific house. And get the current status of a specific device. Now, how would we translate this functionality to REST API actions? Since this is not a full-blown API design course, I won't go through all the factors and considerations of designing the API, but suffice to say that what really matters are usually two main factors: the API path and the return code and contents. Don't worry if you don't know exactly what it means, we will build it together. As you probably remember, REST API defines the entity or entities to be retrieved with a path that is part of the URL and using the get_HTTP verb. So, for example, if I want to retrieve device number 17, I can use something like this. And in return, get a JSON content with the response code 200, which signals that everything is okay and the query has been performed. Now, how would we design the API to comply with the required functionality? Let's look again at what we want to retrieve. We want to get all the updates for a specific house's devices for a given time range. Let's bold the important entities here. We want to get all the updates for a specific house's devices for a given time range. Now, in REST API, when we have nested entities, we always start from the outermost one. In this case, this will be the house, since it contains the devices which in turn contain the statuses. So it looks like this will be the right API for this requirement. Let's look at this URL. We first look for a house with an ID of house ID. The client will place here the ID of the house it wants the updates for. Then we tell the API that for this house we want the devices, and for the devices we want the updates and not, for example, their serial number or firmware version. And what about the time range? This is set using query string parameters. Now, why are the date parameters not part of the URL? Why are we passing them as separate parameters and not like this? The answer is quite simple. The URL contains references to actual entities. There is a house with a specified ID. There are devices inside this house, and these devices have updates. These are all actual entities that have IDs, properties, and functionality. The time range, on the other hand, is just a parameter. It's not entity. The from and to are merely values that help us retrieve the correct updates. And because of that, they are not part of the URL. They are not entities, but only parameters, and therefore are passed as such. Okay, so we have the API path. But what should it return? Well, as we said before, it's extremely important to clearly define what would be the response code for every situation in the API. So, for example, when there are actual updates to be returned, the response code should be 200, which is okay. But what should be returned when the house was not found? What should happen if the client made a mistake and instead of asking for house number 101, it asked for 102, and there is no such a house? Well, in this case, the API should return 404, which is not found. When the client will get this response code, it will know something was wrong with the data it sent and perhaps try again, this time with the correct ID. So as you can see, response codes play a significant role in the API design, and you should thoroughly think about them. Some junior architects do not understand the importance of response codes and always return 200, okay, from the API, regardless of the actual outcome of the request. Be aware of that, and always return the correct response code. Okay, great. So we know how the first API method should look like. In this table, you can see all the methods we discussed, complete with their path and response code options. Take a good look at it and make sure you fully understand why they are designed like this. Now, this table is extremely important in the architecture of the service and should be part of the architecture document. Be sure to include it there, as it will guide the developers about the actual implementation of the service. Okay, great. We now have the architecture of this service in place and we can go on.